Hi everyone, today we're going to be talking about the interior angle theorem in geometry. The most basic case is for a triangle, so let's start with that and then we'll move on to bigger polygons with more sides. A general triangle will look something like this. So let's draw it and we'll call it ABC. We'll label the angles like this with 1 dot, 2 dots, and 3 dots. And what we want to do is find the sum of these three angles in some generic way that doesn't depend on the triangle itself. And miraculously, it turns out it is possible. Our technique is going to be to draw a line through A that is parallel to BC. And what we're going to do is we're going to put a dot here, let's say a vertex of some sort, call it D, and we're going to put another one on this side and call it E. And now we're going to use what's called alternate interior angles. Alternate interior angles tells us that if we have two parallel lines, then this angle is equal to this angle, and this angle is equal to this angle. So let's use that here. We have an angle ABC, and we have an angle DAB, and that lets us say that angle DAB is equal to angle ABC, and similarly we have angle ACB, which we can say by alternate interior angles is equal to angle EAC. So angle EAC is equal to angle ACB. And those are going to be our equations that we're going to use to find the sum of all three angles. Now what I want you to notice is this. We can do a substitution. We're trying to find angle ABC plus angle ACB plus angle BAC, right? So ABC is this one, ACB is this one, and BAC is this one. By substitution using these equations, we get this is equal to angle DAB plus angle EAC plus angle BAC. Now notice what these angles are. DAB is this one, EAC is this one, and BAC is this one. So together they equal 180 degrees. And that gives us the formula that we want for the sum of the three interior angles of any triangle. Let's generalize this to any convex polygon. So let me define for you the definition we're going to use for a convex polygon. A convex polygon is going to mean that it's a polygon, so we have a bunch of line segments that come together, but it satisfies the property that if we have a point either on the interior or on the boundary, and another point either on the interior or the boundary, then when we connect them, it does not go to the exterior. It stays in the interior or the boundary, this line segment. So that's what a convex polygon is. There are other characterizations, but this is the one that we're going to need. And we want to find the sum of the interior angles of an n-sided convex polygon. It's called a convex n-gon. For n greater than or equal to 3. We already know for n equal to 3, but we want to know the answer for more number of sides. So let's see what we can do about that. Let's draw a generic, let's say a pentagon. And this is convex. The idea is to take a central point, some general point in the interior, and to connect it to all the vertices. And what happens is that you get n triangles, and this angle is good, this angle is good. By good I mean it's a part of a certain interior angle of the pentagon. We have this angle, this angle, this angle, this angle, this angle, this, and this. So we have a whole bunch of good angles, but we also have this 360-degree angle that we have to remove. So what we end up getting is the sum is 180 degrees times n, because we have n triangles, minus 360 degrees. And that is equal to 180 degrees times n minus 2. So that's our formula for a convex n-gon. I just want to show you one other method that we could have used. So if this is our pentagon again, then what we could have done is that we could have selected one particular vertex and connected it to non-adjacent vertices. There are two adjacent vertices, this one and this one, so we don't have to connect to those. But we have n minus n minus 3 other vertices, and that creates n minus 2 triangles. So we have 1, 2, and 3. So that once again gives us 180 degrees times n minus 2. So that's a different method, but I prefer the first one. I want to leave you with a comment about regular polygons. So let's say we have a regular pentagon. That means the interior angles are all the same. So if the interior angles are all the same, then each one equals 180 degrees times n minus 2 over n, and that equals to 180 degrees times 1 minus 2 over n. So that's the formula for individual interior angles of a regular polygon. And notice that as n goes to infinity, this goes to 180 degrees. This means that the more sides we add and the closer we get to the regular polygon being a circle, the interior angles get closer and closer to being 180 degrees. Okay, thank you for watching, and I'll see you next time.